This is a question from multivariable calculus. We are given a function in two variables. We need to choose the right option at the origin. At the first sight of the function, we can see that the function is symmetric in x and y. That is, if we interchange x and y, we will end up with the same function. Since it is a symmetric function, we can strike out this option because partial derivative of f with respect to x and y, either both should be continuous or both should be discontinuous, the function being a symmetric one. Now let us check whether the function f is differentiable or not. Here is how we check the continuity of a function at a given point. This is the definition of continuity of function at a point. A function f is said to be differentiable at a point x, y if the change delta f can be expressed in this form, where a and b are constants and phi and psi are functions of delta x and delta y, and they should tend to 0 as delta x and delta y tend to 0 simultaneously. Let us check whether the function is differentiable at the origin or not. So we find the change delta f at the origin. This is by the definition of delta f. Value of the function at the origin is 0, and since delta x and delta y are not 0, their product is also not 0, and so the value of this function at delta x delta y will be obtained from this expression. Now this expression can be written in this form, and we can compare here. We have a is 0, b is 0, and this is phi delta x delta y, and this is psi delta x delta y. I leave for the students to find out how this limit as delta x delta y tends to 0 goes to 0, how this is 0 and how this is 0. So we have this expression delta f is expressed in this form, where phi and psi both tend to 0 as delta x and delta y tend to 0. So we can say that the function f is differentiable at the origin. So since we get f is differentiable at the origin, this option seems to be true as of now. Now since f is differentiable, this option is striked out. Also we know that differentiability implies continuity. That means the function is also continuous at the origin. So this option is also striked out. Thus we can say that option D is the right option, and we don't need to check the continuity of the partial derivatives of f with respect to x and y at the origin. So option D is the right option.